So you might think for your project, what you need is a RAG pipeline, the ability to take documents, chunk them, create embeddings and so on, take a prompt from the user and generate an answer. And what I'm going to argue in this video is that actually what we need is a runtime. That RAG is just like a small piece of the whole story. So let's look at the architecture that we often see. Documents, chunking, turning the documents into chunks of text, generating embeddings, setting up a vector database, retrieval, prompt, and getting an answer. So this is good for kind of questions and answers based on a document. And it's good for like showing citations for how you get your answer. But what I would say is what I've seen is, for example, a user might be shown a demonstration of the RAG system. They'll upload a PDF and they'll just say, summarize this PDF. And this breaks for RAG straight away. So literally like the most popular thing that a user will do, the pipeline doesn't give good results for it. So the demonstration might be, if it's more controlled, an RFP, by the way, is a request for proposal. So this is a way that enterprises can bid for work, say from governments or other agencies. So the demonstration using RAG might be, what does this RFP want? And what I'll argue is that this is probably the wrong setup for the demonstration, because if we look at what the actual user wants to do is to respond to an RFP. And that response might need lots of documents like a compliance matrix, clarification, spreadsheets. So if we keep RAG as human in the loop, then of course we might want to summarize an RFP. But actually, if we look at the complete workflow, it's to actually generate all of the artifacts that an RFP requires. And this is quite a piece of work. It takes a long time. It requires often experts from different industries. And that's kind of what we get with a model. In a model, we kind of have expertise from all of this different industries. So why don't we get the model to generate the complete package, not just like answer a few questions and keep the human in the loop? So let's look at a possible workflow. So we read the RFP, extract requirements, classify, build matrix. There's so much stuff going on actually that we can do. Why does the RAG pipeline not solve that? Because it's basically a question and answer pipeline. It's not really there for completing tasks. So it can't manage the workflow state, create multiple artifacts, validate support claims, and so on and so on. So what I've done here is, if you imagine the model has one tool called execute Python, okay? And then what we do there, we sort of take a mixture of Codex and Claude Code, and we give the model a simulation of a runtime. So the model can create Python code, which models are really good at doing that. And in the system prompt, we say to the model, okay, you have a working environment where you can run Python code. There's a bunch of files like skills, you've got a project folder. If you create any artifacts, then you generate them into the project artifacts folder. So what we've done is brought in kind of all of the Claude Code things like skills, the ability to run commands, the ability to create code and run functions. And this is our runtime. So how would that look? So if I show you a file tree, we've got the files that we use as a reference. So this is maybe what you would have done with RAG. So the user could have uploaded these files, but we haven't put them through a RAG pipeline yet. And that's because sometimes the model might just want to read the whole file. And because we've given it these Python functions that can do that, it can choose to use that capability. we've given it some skills. So we have an RFP response skill, and this would align with the way that the enterprise wants to generate RFPs, like following certain guidelines, making sure certain conditions are met. I've added in memory, so perhaps as the user is walking through the chat, they might, for example, be inside a project, and we can give them the capability to reference other chats. So we're giving the model the capability to do that. And here you can see the artifacts folder. So the model is working through and generating artifacts. And there's going to be a certain amount of persistence there. So as we go from one question to one question in a conversation, when the user asks something more from the RFP response, we're going to need to set up this file structure once more. So you might think about, for example, if we were running in Kubernetes, maybe we have a container that has this file structure. But what I want to show you really is using something like Monty Python, which is like a Python simulator written in Rust. We actually don't need to do that. We can actually intercept function calls that the model makes, and where it might say, okay, give me the contents of this file, perhaps it calls a cat function, we can intercept that and just go to the database or go to S3, pull out the file, rip the text out of it and give it back to the model. So we don't necessarily need to manage lots of containers and so on. We set up a simulation. It's almost like a simulation of what Claude Code would see. Going back to RAG or similarity search, it just becomes a Python function that the model can call. If it wants to do a similarity search through a document, it can call this function, okay? We intercept that function, and then we can decide, do we want to chunk this document actually and store it in the database, or maybe we just do this in real time. So we chunk it, we create the embeddings, we do the similarity search and give the results, and we might want to cache what we've done there. And in theory, we should be using up a lot less resources then, because we haven't run RAG on every single document that the user has uploaded, and we might never even need to run the similarity search on those documents. Potentially, we're saving database space and storage space. So what would the architecture look like? Well, the chat user interface, connected to the model, and I've given it one tool definition, execute Python. And from that, of course, we would need to set up the system prompt and tell the model exactly what it has access to do in that Python runtime. And in that system prompt, we're going to say, okay, you've got files that the user's uploaded, skills, for example, generate presentation or RFP. It can do similarity search. And we can also give it access to integration. So for example, we might give it access to Gmail. And the way we would do that is we would tell it it's got a Python function called Gmail, and that if it needs more information, run the Python function help with Gmail inside. And with that, you get a certain amount of discoverability. So rather than in the system prompt, we tell it all of the Gmail functions that it's got access to, we just tell it to call help. And then in the runtime, when we intercept that call, we can put that into the context. And this, by using discoverability in that way, the context becomes smaller, and we can add lots and lots of different integrations, Gmail, or perhaps Google Drive, Dropbox, or whatever. And the model can just pull those in as it needs them, and it doesn't have to have them all at the same time. And from this architecture, what we're going to see is final products, spreadsheets, documents, markdown, perhaps it even zips them up. We can give it everything that it needs to complete tasks and not just do a search. So I'll put a link to the Monty Python runtime in the description, but basically what we're doing there is the model's going to write Python every time it wants to do something, and we're going to run it in our simulator and intercept certain stuff. And because we're doing that, for example, when we're accessing Gmail, we're going to know it's doing that, and we'll have already done the OAuth2 authentication, so we can add like these security tokens into the REST requests. So we've completely abstracted away the sort of secrets. They're not going to be inside this runtime. We're going to intercept calls, add the secrets in. And that's what we're saying here, basically. Intercepting the function calls. If they need a secret, like an OAuth2 token, an API key, we can add that to the request, forward the request, get the response, and return the response to the model. And you can see that here as well. There's going to be a whole bunch of OAuth2, and you can see here the way that we're going to present these function calls to the model. So there, this is what the architecture could look like. Use a chat-viewer model, execute Python, this Monty Python runtime, and producing artifacts. The artifacts are what we show back to the user in the chat.